Hello everyone. Today we want to learn how to graph a rational function based on whatever we've discussed in the last session. So for example, if I have this function f of x is like x cubed minus 7x plus 6 divided by x squared minus 3x minus 4. So if I have this function, so I want to graph this function based on like those things we discussed, but imagine I don't know how to calculate derivative. So then the like some general techniques would be these things we're gonna discuss now. So the first thing is, so I'm looking at the numerator and denominator, and if I can find any common factor. If you remember, we said if there is any common factor between numerator and the denominator, that would be a whole in the function. So then I can rewrite this like this. So x minus 1, x plus 3, and then x minus 2, and then divided by x minus 4, x plus 1. If you don't know how, you can put a comment for me, and then I'm gonna explain these process. Okay, so I have this function now. Then do I have any common factor? Like, is there any common factor here? No. So then common factor, so common factor, then no. So then there is no whole in the graph. Okay, now the next step is, so I'm gonna look at the domain of this function. So as you know, domain would be any real number except 4 and negative 1. And then we discussed this also. X equals to 4, x equals to 4, then x equals to negative 1. Those are vertical asymptotes. Okay, now I found vertical asymptotes. So is there any other kind of asymptotes? So we're supposed to look at the power, the exponent of the leading terms in the numerator and in the denominator. Now if I look at the numerator, so that is 3. In the denominator is 2. So then because the power of the leading term is 1 unit greater than the power of the leading term in the denominator, so then we'll have oblique asymptotes. How can I calculate that? Just long division. So then I have to calculate this. So x cubed minus 7x plus 6 divided by x squared minus 3x minus 4, which long division. Then so the oblique asymptotes, so oblique asymptote will be y equals x plus 3. If you don't know how to do long division, so put a comment for me, then I'm gonna explain that for you. Okay, now so I want to graph this function. So then if I have, so let's have, so imagine I'm gonna graph that function here. Okay. So I have two vertical asymptotes. We said vertical asymptotes, the function not allowed to cross or touch at all. So then I'm gonna draw those two vertical asymptotes. So we have x equals to 4. So like here, and then -1 is like here. Okay, so these are vertical asymptotes. Now, I got also one oblique asymptote, so then I'm gonna have oblique asymptotes. So which, if this is, let's have this is +3, then I have kind of like this oblique asymptotes. Okay, now, so for the function, I can get some like little bit more information on this function. So I can find x-intercept. So x-intercept. For x-intercept, we have to plug in 0 as y, right? So then y is gonna be 0. Then if I want to have y equals to 0, then the whole fraction, the whole function should be 0, and then the rational function will be 0 if the numerator is 0. So then, so I have to have x cubed minus 7x plus 6 is 0. So then the x-intercept, so x-intercept is gonna be -3 and 0. It would be 1 and 0, and then it would be 2 and 0. So then so -3, so this was -1. So then -3, 1, +1, and then +2. So then these points are x-intercept. And how would be y-intercept? So for y-intercept, x should be 0. And then if x is 0, then y-intercept, so it's gonna be 0 and -3/2, which is like almost here, -3/2. So then here. Okay, once I have two vertical asymptotes, and we said the function not allowed to touch or cross, then it means I have a three-piece function. So then it means I have like a one piece here. So this is one piece, the second piece here, and then the second piece here, the third piece here. So then I have a three-piece function. Okay. And now, so if I have three-piece functions, so then I have several options to graph this function. So if I want to have this, like for the first piece, like for this piece, so I have two options. I have one, like starting in Q1, this is Q1, or starting in Q4. Then which one should be correct here? So then I have to check ending behavior. And then we said for ending behavior, so then ending behavior So I'm gonna take the leading term in the numerator and then leading term in the denominator. Then I'll have, so almost I have x as the ratio. So this is ratio of the leading terms. Then if I have x as the ratio of the leading terms, so then it means if I have x approaching a positive number, then y is positive. If x approaching to a negative number, y is gonna be a negative number. But then if that is, if x is a big number, then y also could be a kind of big number. It's not a small number at least. And then if x is a negative infinite number, is a negative big number, then y also is going to be a negative number, but not small negative numbers. So it means if x positive, y positive, then it's going to be q1. And then if x negative, y negative is going to be q3. So then one of my ending behavior would be in q1 and another one is going to be in q3. So then I'll get back to this. So then so my function will be in this quadrant here. So then starting here, and then another ending point would be in q3, which is here. So this is q3. So then I know then the function won't have any piece in q4 because as an ending behavior is not going to be in q4, right? Okay. Now, so then I know I'll have in q1, and then if I want to graph this part, so it's like this. So I have in q1 ending point. So then ending point for a big x, which is like, imagine this is a big x here at this point. Y also is going to be kind of like big number. So then it's going to be like somewhere here. So then if it is an ending point, and then also I'll have the like vertical asymptote. So then I'm gonna have this piece like this. So then this the third piece, I mean the first piece, so it's gonna be like this. This is the first piece. Okay, and then the third piece, so I have something like for a positive, so like for a negative x, I'll have a negative y. So then I'm gonna have something like somewhere here. But the thing is, if I have a very big negative number, y is not going to be a small number. So it's going to be like at least not a small number. So then I'll have somewhere here. So also you can put some points. You can plug in some points here to get like some rough data in Q3. So then I'll have something like this. So then I start from this point, for example, and then so one of the x-intercept is x equals to -3. So then it means, so I have to pass through this point. So I have to pass through this point, and then so once I'm approaching the vertical asymptote, so it's not touching this and then goes up. So then I have the third piece is something like this. So then this is the third piece. And for the middle piece, I could have several options. So then for the middle piece, So I'll show you here. So if I want to have like, so imagine this is the middle piece. I can have several options. One option would be like this. I might have something like this, or it could be something like this, like U shape, like upward, or U shape downward. So these are all possible options for the middle part. But then how would be this? So because I have two x-intercept, so then it means the function must pass through these 2 points. And also I have y-intercept, which means the function must pass through this point also. So then I can imagine I have kind of U shape because I have to pass through these 2 points as x-intercept. So then do I have like U shape upward or U shape downward? So then I can easily check the points very close to the vertical asymptotes, because we said vertical asymptotes would be a crucial crucial points for us. Then like those lines matter to us. So then I can calculate, for example, so this is -1 and then this is +4. So then I can check, like for example, +3/2, which is very close to this. And then also I can check like -1/2, which is like this point here. So then I can find y of those 2 points. So then for f -1/2, so the y amount would be almost -4.117, which is a negative number. So then it means for x equals to -1/2, y coordinates of this point will be a negative number. So then it's going to be a negative number. So it's like somewhere here, for example. So then this point is going to be y coordinates of this x. And also, if I calculate like f7/2, so then that is going to be also a negative number, which is -10.8 almost. So then for this, so it's going to be -10.8. So then what does that mean? So then I can fill this function will be a U shape and downward. Why? Because if I had like the function as U shape upward, something like this, for example. So if I had something like this, so something like this, it wouldn't be possible because I have these 2 points very close to the vertical asymptotes in the top half, which is like all positive y. However, I have for those points close to the vertical asymptotes, y of those points are negative. So then it means I have U shape, but then downward. So then it's going to be something like this. So then this is that function we wanted to graph. So then this is one of the easiest option, I think, for any rational function. You can graph those functions very like accurate. So there are some critical points, some crucial points, I mean. You have to calculate any vertical asymptotes. You have to find any oblique or like horizontal asymptotes, and then check if there is any hole on the function. And then so you can find also x-intercept and y-intercepts. And then so you can check ending behavior and also behavior of the function very close to vertical asymptotes, because we know once function approaching to the vertical asymptotes, it never ever like touch that or cross that. I hope you learn well. If you have any questions, feel free to ask. You can put any comments, any questions, or any topic you're interested to learn. Then I'm gonna teach those things in the next lesson. Thanks for watching.